In this video, we're going to look at the learning target. I can simplify square roots, but we're specifically going to look at what happens when you have a negative number underneath the square root. Okay, so each of the examples are going to have a negative number. Now, off to the side, once again, I listed off our perfect squares for the numbers from 1 to 15. Okay, so if you want to take the time to do that, you might want to do that. And then we're going to look at this first example. So here I have the square root of -1. Now, if you remember, a square root is really asking you for the number that when you take that number and square it, it should give you the number underneath the radical. Okay, so we're looking for a number that when we square it will give us a -1. Well, our options in our head, you're probably thinking, well, maybe -1 would work. Okay, so say we plug in a -1 and squared it. Well, -1 is really the same thing as -1 times -1, right? And when you take -1 times -1, well, negative times negative gives you positive, and 1 times 1 gives you 1. So you don't get -1, you get +1. So -1 doesn't work. Well, if you tried +1 and you squared it, well, 1 times 1 is just +1 again, right? You can't get a -1. No matter what number you were to try and square, because when you square a number, right, when you take a number times itself, if both of them are positive, well, then your answer has to be positive. And if both of them were negative, well, negative times negative, your answer would still be positive. So you'll notice that it's impossible to get a negative number underneath the radical. Okay, it doesn't rationally work out because of this problem of a positive times positive gives me a positive, and negative times negative gives me a positive. But we call this number the imaginary number, and we say that it equals I. Okay, this is known as the imaginary unit. Okay, imaginary unit. It's called imaginary for the reason that I just talked about. It doesn't exist because it can't logically work, but we'll find out in a little bit that it actually has mathematical implications as being the imaginary number. Okay, and it's called the unit because it's the most basic imaginary number. And we're going to look at number 2 here to show how we use this. So let's say I had the square root of -16. Normally, because it's a negative number, I wouldn't be able to simplify this. However, I can use I, the imaginary unit, to help me simplify this. What I can do is I can rewrite the square root of -16 as the square root of 16 times the square root of -1, right? Because 16 times -1 is -16. Well, the square root of -1 is imaginary, right? It's the imaginary unit that we just saw. So I'm going to rewrite that as just I. It's imaginary. And then the square root of 16, that's asking me what number squared gives me a 16. Okay. Well, I can just look at my chart here. 16, the square root of that, what number squared gives me a 16? Well, that would be 4. So the square root of 16 is 4. So if I take 4 times I, the imaginary unit, I just get 4I as my answer. I get an imaginary number. All right, let's go ahead and look at number 3, a little bit more complex problem here. Here I have 3 times the square root of -72. So this number out front, I'm just going to leave out front for now. But I want to break apart this radical. So what I'm going to do is I'm going to rewrite it as the square root of 72 times the square root of -1. Okay, I'm taking the negative off. I'm doing that so that I have a positive number underneath the radical so I can simplify it. And I know the square root of -1 is going to be the imaginary number I. Okay, so this is going to be I here. Now, the square root of 72, I need to think of what is the biggest perfect square that goes into 72. So if I look at my chart of perfect squares, I have 1, 4, 9, 16, 25, 36, 49, and so forth. And the biggest perfect square that's going to go in evenly to 72 is going to be 36, right? 36 times 2 is 72. So I can rewrite 72 as the square root of 36 times the square root of 2. And then I'm still multiplying by this 3 out front. Now I want to simplify the square root of 36. So if I look, the square root of 36 is 6, right? 6 squared gives me 36, so the square root of it is 6. So I can rewrite this as 3 times 6 times the square root of 2 times I. And then we can just multiply the two numbers out front. So 3 times 6 is 18. And then we're still multiplying the square root of 2 times the square root of, or times I, sorry. And then the last thing I want to mention is just how we write this. Typically, our formatting when we write our answer is we write the number first, and then we write I, and we leave the radical, the square root of 2 on the end. The reason why we do that is because sometimes when we're writing fast, we write a little sloppy, and you can write it where you do something like this, and it'll look like the I is underneath the radical, but we don't want the I to be considered underneath the square root symbol. So we write it in front so that the radical is always at the end. So there's no confusion over what's underneath the radical and what's not. So it's always number, then I, and then the square root on the end. All right, let's look at one last example here. So in number 4, I have the square root of negative 20. So because it's negative, I'm going to rewrite it as the square root of 20 times the square root of negative 1. Okay, and once again, that's just pulling the negative off so that I can simplify the square root of 20. The square root of negative 1, as we saw, that's imaginary. Okay, doesn't exist. So I write I for the imaginary unit. And then I got to figure out what perfect square goes into 20. So when I look at my chart, I have 1, 4, 9, and so forth. Well, the biggest one that's going to divide into 20 is going to be 4. So I can break 20 into the square root of 4 times the square root of 5 times I. And then the square root of 4, well, what number squared gives me a 4? Well, that's just 2, right? So I get 2. And then this again is just formatting. So the square root of 4 is 2. Then I'm going to write I, and then I leave the square root of 5 on the end of the problem so that there's no confusion over what's underneath the radical. And then this would be the simplified form. Okay, so with imaginary units, there's just that one extra step of pulling off the negative and getting the imaginary number. And just remember that the imaginary unit is the square root of negative 1, and for shorthanding it, we just write I as the shorthand of this.